Hey developers, in this tutorial we will explore the essential concepts of handling useEffect dependencies in React. You'll learn how to remove dependencies, handle linting rules properly, read a value in your effect without causing unwanted side effects, and avoid problems like infinite loops and unnecessary re-renders. In our first code segment, we have an effect for our chat application. This effect sets up a chat connection using a server, URL, and a room ID. However, we run into an issue when the dependency array is empty. The linter raises a warning about a missing room ID dependency, which we should not ignore. We can fix this by including room ID in our dependencies. By doing so, React will keep our effect updated whenever room ID changes, ensuring our chat connection stays current. But what if we want to exclude room ID? By making it static and lifting it out of our component scope, we prove that it's non-reactive. Now that room ID doesn't change on re-renders, it no longer needs to be a dependency. Let's emphasize the important rule. Modify surrounding code first when changing dependencies. It's crucial to describe your effects code with the dependency list. Here is an example of a common mistake: reading a value in useEffect without reacting to it. We want the effect to only be executed on mount, and therefore we pass an empty array as the dependency list. The linter complains about the missing dependency, but we ignored it. This counter was supposed to increment every second by pressing a button. However, since we lied to React that this effect doesn't depend on anything, React forever keeps using the onTick function from the initial render. During that render, count was 0 and increment was 1. This is why onTick from that render always calls setCount 0 plus 1 every second, and count stays at 1 forever. To fix this bug, we need to add onTick to the dependency list so that React knows to update the effect when onTick changes. Now let's focus on another question. Should this code be an effect at all? Let's consider a scenario where we're working with a form. Once the form is submitted, we update a state variable submitted to true. We have an effect set up that reacts to submitted being true, and in response it sends a post request and displays a notification. Later, we want to modify the notification to show a different style based on the current theme. As the theme is declared in the component body, it's a reactive value. So naturally, we add it as a dependency. By declaring theme as a dependency, we unintentionally cause a bug where changing theme triggers the effect and displays the notification again. Instead, we could have driven the logic by the form submission event, not by state changes. By doing this, we isolate the action to when the form is submitted and avoid unnecessary re-renders. When we read state in order to calculate the next state, it is often easy to introduce an infinite loop. Here we have a counter that increments every second. We put the counter in an effect and set the effect to run every time the count changes. However, we're reading the count state in order to calculate the next state. This is a problem because the effect will run every time the count changes, which will cause the count to change again, which will cause the effect to run again, and so on. To fix this, we can use the updater form of setCount, which receives the previous state as an argument. This way, we can increment the count based on the previous count, instead of the current count. With this change, the effect will run only once on mount, preventing any infinite loops. Lastly, let's discuss potential issues when dealing with objects as dependencies. The issue here is that every time the component re-renders, the object gets created again. As a result, the effect will run again, even if the values inside the object didn't change. In JavaScript, objects are compared by reference, so even if the values inside the object are the same, the object itself is different. Object and function dependencies can make your effect resynchronize more often than you need. This is why, whenever possible, you should try to avoid objects and functions as your effect's dependencies. In this example, we could move the object declaration into the effect. Now that options is declared inside of your effect, it is no longer a dependency of your effect. A second option is to extract the primitive values out of the object. In this example, we can extract the room ID and server URL values out of the options object. Since strings and numbers are compared by value, the effect will only run when the values change. That concludes our tutorial for today. Don't forget to subscribe for more fast-paced coding content. Stay curious and keep coding.